Hi everyone, today we're going to look at two-dimensional views of solids. We'll find the two-dimensional figures that we see when we're looking at solids from different views, such as the top view, the front view, and side views. Here are a number of three-dimensional objects from my home. We're going to have a look at the views of some of these. This is a box of coffee pots. And you can see that the box is a rectangular prism. The top view is called the plan view, and sometimes people call this the bird's eye view, because when you look at it, you can imagine a bird flying over top and looking down and what they'd see when they look down on top of that box. For a rectangular prism, the top view is a rectangle, and the view from the bottom would be exactly the same as the one from the top. Here we have in front of us the front view of that same rectangular prism or coffee pot box, and the shape on that is a rectangle, and it would be exactly the same at the back as well, but the rectangles are larger this time than they were for that top view that we had before. For our side view, we also have a rectangle, and it's the same height as the front view because the box is the same height from the front or from the side, but it's narrower, and it would actually be the same width as we had for the width on the top view. So if we could draw the views then of those solids in a two-dimensional perspective, this is what we'd see. From the top view and the bottom, we'd have that rectangle. From the front and back, we'd have that larger rectangle, but you can see that the width of both the top view and of that front and back are the same. And the side view is as tall as the front and back views, but the width of the side view is the same as that narrower width on the top view. So now I've created an L shape out of two coffee pod boxes. I want you to imagine that they're actually glued together and they're not two separate pieces. So in this, you can see that the front view is an L shape, but the angle at which I'm looking at these boxes at the moment, I can see the front, which is that green L, and I can also see the top surfaces in the yellow there. So we're seeing from the angle that we're looking at, we're seeing two different surfaces. When we start to look at the actual views from particular sides, we want to imagine we can only see one surface and one view at a particular time. So if I want to look at that same L-shaped coffee pod box, but directly from above, the bird's eye or plan view, then what I see is I've got a top surface that's up higher, another top surface that's sitting down lower, but when you put those two top surfaces together, you just get a rectangle. However, there is a change in the height between the two, and so what we do is, to show a bend or a change in the dimensions, we put that line across to show that there was that bend there. For our side view, we've got the L shape. And in this particular instance, both boxes, which we're pretending are one L-shaped box, have the same surface. There's no bend in that surface on the front, so we don't have to put any additional lines in that front view. So now we're looking at the same L-shaped box, but this time we're looking from the right side and from the left side. Now on that right side, the top section of the box is back further than it is from the bottom section of the box. So there's the top section, but that right side face is shown, and there's the bottom section of the box and the right side face shown. And when you look at those two faces together, again you get a rectangle. The only thing is that there's a change in the or a bend in those particular boxes when I take the two faces back away, and so I need to put a line across where there's that bend. For the other side, the left-hand side view, again remember we're imagining those two boxes are actually stuck together, so they have just one consistent face on that side, which is a rectangle, and you don't show any additional lines in that because there's no extra bends, it's just one surface on that particular side. So if we were then to have a look at how we would draw those different surfaces from different views, so two-dimensional views of that three-dimensional solid, this is what we would see. From the top, we would see the rectangle, but showing the bend, we'd have the line. From the bottom, it would be the same size as the top view, but there's no bends in there. It's just one solid surface, so there's no extra lines. From the front, you see the L shape in the way that matches the box. But if you were to look on the other side, you'd actually be looking at it in reverse, so the back view would be reflected. On the left-hand side, you've got a solid surface, no bends in there, and a rectangle. But on the right-hand side, we had that bend, so we had to show the little line across. You'll notice that the height for the left side and the front view and the right side and the back view are all the same height because they're representing the same dimension. The width of the top view and bottom view is the same as the width of the left side and the right side. Again, they're representing the same dimensions. So we move on to another common object from home, and this is a cylindrical bottle. And for this one here, I want you to think about what you'd see from the top and from the sides. So here's a top view and here's a side view. And for that top view, you can see that we're going to have a perfect circle. And if we look instead at the front and side views, again, because this is circular, there's really no front and there's really no sides other than the labelling that's put on it to show us where the front is. But no matter what view we look at, front, side, back, we're always going to get that rectangular shape. Now you might talk about the bottom looking particularly like it's a bit curved, and that's only because we're still seeing that in 3 dimensions. I wasn't able to get the camera view down so that it purely looked like it was in 2 dimensions. But if we could genuinely see it in 2 dimensions, we wouldn't get that depth there and we'd get just that rectangular shape. So what would we draw if we were asked to draw the views of that particular solid? Our top and bottom views would be exactly the same. We'd have a circle. The front and back views would be that tall, narrow rectangle, and the side view would be an identical tall, narrow rectangle. YOLO, you only live once. I want you to think about what you would see from the front, the top and side views for this particular figure. Okay, so there we have it, and this is our front view, and I've taken it down now so that it's looking far more two-dimensional. And there is a tracing of the front view of our hashtag YOLO. What would you see from the top? Well, the top is actually a rectangle. It's just that we would have to put those extra little lines in to show the bends and the change in the dimensions of that. So we've got the top view is a rectangle with those extra lines, as is the side view, which is also just a rectangle if you look purely on from the side, but we've got the extra lines in to show where we're having bends in our hashtag YOLO. So what would that look like if we're being asked to draw the two-dimensional views of our hashtag YOLO solid? From the top, you'd have the rectangle with the extra lines in for the bends. From the front, you would have the shape of hashtag YOLO. From the side, again, you've got a rectangle with the extra lines for the extra bends, and that's coming from the side next to the hashtag, because you can see next to the O, it's a much smoother shape. There's not so many bends in there. And if I did the back view, it's going to be a reflection of that front view. So what are the two-dimensional views of our trusty toilet roll? Well, there's our top view and there's our side view. And just as with our cylindrical bottle, the side is really anywhere and the front is really anywhere because it's the same from all angles. So for our top view, we don't just have one circle this time, but because there's that hole in the center, we've got two concentric circles. And concentric circles means that they're a different size circle, but they have the same center. So the central circle is balanced in the middle of the outside circle. For our front and side views, you can see, just as we did before with the taller cylindrical bottle, that we're going to have rectangles. Again, we're still seeing this slightly in 3 dimensions, so we're getting that bit of a curve in the bottom, but if we could purely see that in 2 dimensions, it would be a rectangle. So what do the views look like? The top and bottom views are the concentric circles. The front and back views and side views are all rectangles of exactly the same size and shape. So now we're going to change things up a little bit, and we're going to say, I'm going to give you the views and you've got to work out what it would look like if it were a solid. So we've got a solid here in which from the top you've got those concentric circles. From the bottom you've got just one circle. And from the side and front and back views, you can see that they're exactly the same. So that makes sense because we've got that circular shape when we look down from above, or the plan view. So what do you think the solid might be? A shampoo bottle. Well, you might not have picked a shampoo bottle, but hopefully you picked some sort of bottle of that kind of shape that has like a screw top or a flip top lid. And the reason why we needed that extra circle on the top is because of the lid there. And you can see that it kicks in at the top for a little cylinder on the top. Okay, let's play Which Solid number 2. This time your top view and bottom view are slightly different. The front and back views are a V shape and the side view is just a rectangle. So what do you think we have here? We've got a V shape. And the reason why the bottom view on the previous slide showed a narrower rectangles or lines in the middle there is because you can see that there's only the 2 bottom edges of the bottom of the V, but you can still, from the bottom, see the top of the V, which is why you've got the full width of the rectangle. But there's the extra central line that you would see if you were looking down from on top. Okay, which solid number 3? So this one has a top view of a circle, and if you have a look at the front and side views, again, they're exactly the same. And they have 2 trapezia. So there's a longer, narrower trapezium on the top and a wider trapezium on the bottom, or taller trapezium on the bottom. So what do you think that this solid might be? A little pot. But anything, it could have been like a can, like a bucket was what I was thinking of. But something where you've got that shape getting narrower towards the bottom. Okay, our final which solid. Our final which solid is not a solid you typically find at home, and it doesn't have a name to it, but I want you to have a look at what the information you're being given. So the sides this time have been color coded. From the top in green, you can see that we've got those squares. From the front in red, if you're looking at the front view, you're going to see something that goes as high as 3 squares high and as low as 1 square high on the right hand side. And for the right view, it's equally as high as the front view. And you can see that that one's color coded in blue. So this one doesn't have a name, but I want you to think about how you put that together and what you would come up with if you were to try and make out of cubes that particular solid. So drum roll, this is what it should look like. There's your 3-dimensional solid. It's going 3 cubes high, as low as 1 cube, And again, the color coding shows the green top surfaces, the red front surfaces, and the blue side surfaces, right side surfaces. So it's now your turn. You're going to head back to your Google Classroom to see the work that you need to complete from your textbook. Thank you so much for watching, and good luck with drawing your two-dimensional views of three-dimensional solids. Bye everybody.